So first of all, thanks for coming. That's my first talk ever, so sorry for that. Okay, so my talk is called Speed Wins, the basics of how to push more queries through each CPU core. My name is Aitana, and I've been working at Tinybird as data engineer in the customer success team for exactly a year tomorrow. And I've been recently promoted to lead data engineer. So during this talk, we are going to review how we were able to reduce by 99.94% the query time and 99.99% the process data in a real use case. You might be wondering why this is important or why we focus on that. And well, our goal at Tinybird is to allow our customers, to have real-time analytics project. So to be able to have a real-time analytic project, it's super important, or you should focus on reduce the query time as much as possible until you have a really low latency query. Because if your query takes minutes to be executed, you are not going to have a real-time analytic project. So we try to reduce always as much as possible the query time until we have a really high performant endpoint that will allow us to have a real-time analytics project. Okay. But our goal at Tinybird is not just to allow our customers to have real-time analytic projects, but also to have affordable real-time analytic projects. Because we know that with a lot of money, you can have real-time analytic projects, right? But it's not what we want to achieve. So we should also focus on try to reduce the process data as much as possible. But by doing that, the same CPU core will be allowed to process more queries, meaning that you can process the same amount of queries with less cores, right? And therefore, you can reduce the cost associated to your project. So that's what we always focus on, reduce the query time and also the process data for each query. So to explain this, this better, we are going to use a real use case, for instance, an e-commerce, which is selling different types of product all over the world. And the purchase can be via website or application. So let's suppose that the goal of this e-commerce is to track how a clothes sales campaign is performing via in the application, performing in real time, so that they can take decisions as soon as possible and also spending as less money as possible. So for this case, we have an events table with, I don't know if you can see it, but the table has over 1 billion rows, 1 billion American billion. So it's like 1,000 million rows. It's like around 30 gigabytes. And we also have another table which contains the equivalence between the product ID and the type of product. Let's say arts, music, sports, clothes, or whatever. We have created a dashboard. Let's see, it's working, right? To check how each endpoint is performing. Because maybe if we say like some seconds, we are not aware of how this is working, right? So in this dashboard, we can choose between product types, event type, and we can see the amount of rows that the table contains at that moment, the latest row ingested, and also the response time, the rows read, and the bytes of the query. So how we can achieve this, how we can define this process to get that result? Well, we have the original data, as I said, it's 1.1 billion rows, American billion, and the information is sorted and indexed by customer ID. After that, we can perform the join to add the type, meaning ID1 is clothes, ID2 is whatever. Then we can calculate the quantity of products per minute, event, device, and type. Then we can filter, for instance, the information in the last 3 hours until we get the output, which is this dashboard we have seen. So from the original data until we get the output, we perform the transformation process, right? This is, for those interested, this is the query. As you can see, it's the join in the, let's say, in the middle. Then we have the group by, where we perform the count. And at the end, we have the filter with these 3 hours. And that's how the, that's how the dashboard would perform in this case, right, with this endpoint. This is working. It's not a stop or whatever, okay? It's, I have, let's say I have called the endpoint, and it's taking like forever. Like forever. If I change to buy, here we can say, we can see that it's, well, we cannot see, but it's working until it'll get the output, okay? The response time in this case is more than 8 seconds. It's reading the whole table, all the rows, and almost 42 gigabytes, okay? Just one query, which is crazy. I mean, if we want to use this endpoint for a real-time analytic projects, it makes no sense, right? So we have to improve this process, let's say, this ETL process. So when we in customer success face this problem, when our customers report this kind of problems, of issues, what we recommend them is to go backwards, okay? So it's okay, you have now the output you want to achieve, but now you have to improve your process. So it's time to check, to review the transformation process, and to check what we call the main rules are being applied, and to check the schemas of the data. So what are these main rules? Rule number 1, it's the faithless data is the one you don't write, okay? So if you don't need some data, please don't save it. In a real-time analytic project, this is super important. So because if you save info, data that you are not gonna need, it's going to impact your memory, the money, the queries will take more time. So if you don't need something, don't save it, okay? Rule number 2, the second fastest data is the one you don't read, okay? Meaning that if you want to avoid reading data that you don't need, you should filter as soon as possible using the indexes you have defined, okay? I'm going to show you an example. This is a query that it's filtering based on something that it's not defined as index, okay? So it's reading the whole table, right? It's reading almost more than 13 gigabytes, and it's reading like 1.07 billion rows. It's taking 3.3 seconds, which is crazy. But if we filter based on something we have in the indexes. In this case, is device is set in the as index. It's reading 7.43 gigabytes, and it's around 7 million rows. Okay. It's a lot, but it's what you can hear it or not? Yeah. Okay. Thank you. Sorry. Okay. So as you can see, it's reading less, right? It's now it's there are huge numbers because there are a lot of data in the data source, but it's just reading what it has to read. Rule number 3: sequential reads are 100 times faster. That's it. To have sequential reads, you have to define indexes correctly. And that means that you have to define the indexes based on the queries you are going to perform. Okay? For instance, if you are going to filter, in this case, by device and by the date, in this case, timestamp, same as before, if these columns are not set as indexes, it's going to read the whole table. Again, and this is taking 6 seconds. However, if you define those columns as indexes, it's reading 99 megabytes, just 5 million rows, and it's taking 36 milliseconds. So the difference is huge. Okay, so it's super important to keep this in mind. Rule number 4: the less data you process after reads, the better. That means that once you have applied rule number 2 and rule number 3, you have tried to discard as much info as possible. Meaning that if you, for instance, if you just need 2 columns, right? Just ask for those columns and don't retrieve all of them. Just, because whatever. I mean, just if you just need the date and the product type, just retrieve those columns. Once the rule number 2 and number 3 are applied, applying this rule is not as impactful as the other rules, but everything matters. So this is important too. Rule number 5, and this is the last one: complex operations later in the processing pipeline. Okay, so for instance, always try to filter first, as we have said in rule number 2 and rule number 3, and then once that you have less rows, then you can operate with them, perform a join, a count, whatever. For instance, let's see the difference between first grouping and then filter. The first step, grouping the data, takes almost 10 seconds, and it's again reading the whole table. And then if you filter, it's taking also 11 seconds, okay, and reading a lot of data. But if you filter first and then you apply the group by, then applying the filter takes like 7 milliseconds, which is nothing. And then the group by, it's more expensive, and it took 11, but we are like speaking about half of the time, the data, and so on. Okay, so it's also really important. So if we go back to our case, that's what we have defined, right? We perform the join, then we calculate the quantity, and then we filter the data. So based on these rules, what we have to do is first perform the filter, then perform the join, and in the last step, perform the calculation. That's the query, okay? As you can see, first we are filtering in the middle, then we are performing the join, and at the end we are grouping. And that's how this new dashboard would perform, okay? As you can see, it's still taking a lot of time. So it's not like we have achieved a great improvement yet. I mean, I'm sure that most of us have worked with this kind of dashboard, which is a nightmare. So, it doesn't make sense to be wasting time with this kind of behavior. So in this case, the response time has decreased to 6.6 seconds, but it is still reading the whole table. Okay. Here is the comparison. We have improved the query time a bit, but we have not improved anything else. And this is still not compatible with real-time analytics, right? So we have to keep improving. The next step, once we have verified that these main rules are applied, is to focus on the schemas, on the data schemas we have defined. That's what we have. As you can see, the engine sorting key is customer ID, which makes no sense because we are filtering by product type, event, and date time. So this is not helping us. So if we change to event and timestamp, applying rule number 2 and number 3, we have already explained, which is using the filter first. Filter using the those columns we are using to fit to query. Right? We just applied this change, and this is how the dashboard is performing. Okay, as you can see, it's taking 0.7 seconds when we select the event type view, which has more info than by. Here is now how it's performing, 0.2 seconds. It's reading 46 million rows and 1.72 gigabytes, which is, a big improvement comparing to what we already have, right? So, and you can see, okay, that's acceptable, right? We can go with this option. The dashboard is working fine. Everything, I know, 1.72 gigabytes. It's a lot for a simple query. But I mean, we can stop here. But we have what we call an eyes up our sleeve, which is materialized view, materialized views. A materialized view is a combination of a pipe which reads from an original data source, performs a transformation process, and then a destination data source where this result is stored. Okay? A materialized view works incrementally, meaning that every time that new data is ingested in the original data source, this transformation pipe is triggered, and the result is saved in the destination data source. So that allows us to have the data pre-calculated, and we don't have to calculate everything at query time. So what we can do in this use case is to materialize the join and the quantity calculation, the group by. Meaning that every time new data is ingested, the new events are coming, we perform the join at that time, and we perform the group by. So that's, after applying this materialized view, that's how the dashboard is performing. So as you can see, it's taking like 0.003 seconds. It's just reading like 54,000 rows. And I think it's like 0.002 gigabytes, right? So, I mean, it's pretty crazy, the change, right? These are the, sorry, well, it's after in materialized view addition, that's the numbers we get. So it's I mean, every time I see that, it's like mind-blowing for me because it's like super crazy. And that's how the final dashboard will perform, okay? You can change whatever you want. As you can see, well, we were ingesting at that time, so the total rows number is increasing, and the latest row is also, as you can see, the time is changing. Okay, so this is totally. I mean, it allows you to have a real-time analytics project. If you want to take decisions in real time, it's possible. So I would say that my conclusion is that this is a super low effort with a really high reward process. So just by applying some basic improvements, you can boost your projects. I'm sure that I haven't told you anything that you didn't know previously, because it's like super basic, right? I mean, indexes and so on. It's not. I'm not talking about the latest product in the industry, or something like super. But I would say that 95% of our customer projects are related with that. 95 or 99, but every time that some customer comes saying, "Oh, I have a query that it's super slow," and so on, it's like indexes. I'm sure you are not using indexes, so. So yeah, as I said, it's a really low effort with a super high reward process, and you can you can boost your project by increasing the number of queries you can perform with the same infra, meaning that you can reuse it, or you can even decrease your infra, which is really important. You can boost your project by achieving a really high performance dashboard that will allow you to have real-time analytics. Of course, by reducing the bill, which it's, I know it's probably it's more important for everyone, right? And that's something that our customers usually do by themselves, okay? They have this kind of dashboard that they can take a look whenever they want to see, easily how everything is performing. And this is a real use case from one of our customers, and this change was after applying a Materialized View. So this is something, it's not nothing complicated, it's something they can create by themselves. And once you create one, then it's like a new life for you. It's the improvement. It's crazy. That's the improvement they get. They were like reading 45 gigabytes as we were in our example here, and they were able to reduce it to 2.5, and they had like a 2-second query that they were able to reduce to 30 milliseconds. So, I mean, that's it. I want to explain to you, we are running a hackathon with a space theme. You can participate if you want to. It's using Tinybird, so it would be like a super amazing opportunity to try it. It's free. Tinybird is free, and you can win a M2 MacBook Air. So I encourage you to try. You can come by our booth if you want to. We have some stickers with a QR you can scan, and it leads you directly to our website, to the hackathon website. So if you have any questions or whatever, that's it.